The goal of this video is to bring you up to speed regarding conditional statement in the C programming language. So you have used already conditional statement in other programming language. Maybe you studied Java before this class, or you studied Python. So we're going to focus on the differences and similarities in syntax between those languages and the C programming language. So let's take a look at the syntax itself. So if you come from a language that uses curly braces, like this, in its syntax, then you are going to be in very familiar land here, okay? What you have here is with the C language, we do have a language that uses a curly brace syntax, in order to delimit blocks of code. So what we are saying here is we use the keyword if to say there's going to be a test that's going to be made. Here's a condition that I want to test. For example, let's say that we have a variable value equals 0, okay? And then I'm going to do something with value. I'm going to read it from the user, for example. But then later on, I'm going to say if value equal a certain specific value that I'm looking for, like 42, then I'm going to say execute all of this code right here that I'm highlighting. So the curly brace allows us to delimit a block of code, okay? And in this case, this is a block of code I want to execute when the condition value being equal to 42 is true. Else, another keyword of the C language, very common in other programming language as well, else followed by the block of code that I want to be executed if this condition is actually false. So very simple, very similar, even if you come from Python where we don't use curly brace, but we use indentation to represent the structure of the code. It's very similar, very easy to understand and get your mark. So let's add a little bit more to that code so we have something that we can run and play with. So we are not going to call this value, we're going to call this input, simply because I'm going to invite the user to guess what integer I am thinking about. Okay, and then scanf, read from the user %d, ampersand. So we are going to talk more about that ampersand, but right now we use it as a recipe. Okay, ampersand followed by the name of the variable where I want to store whatever the user types, and here I use the %d format specifier here to say I want to read actually an integer value. So all of this to say, guess which integer I am thinking about, okay, and then read it, and then check if it's 42 that the user specified. Well, we're going to say 42 is exactly the number I was thinking about, okay. So if input equals 42, printf, how did you guess? Okay, else, printf, nope, this is not the one that I was thinking about. Okay. All right. So just to keep everything neat and tidy on the screen, guess the number instead of blah 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 what I'm thinking about. Okay, guess the number. Here I don't know when I introduced that underscore, but it doesn't belong there. Read it, etc. Save the file. Let's compile this. GCC. So the name of my file is main.c. There we go. No compilation error. The default executable being generated is going to be named a.out. So I execute it, I run it by typing /a.out. There we go. Guess the number. I'm going to enter 123. Nope. And then, well, it would be nice if I went to the next line here instead of having the prompt, appear right after. So I'm going to add a little happy printf here. There we go. Run it again. Well, first compile it. Run it again. Guess the number. 1, 2, 3. Nope. Did I forget to do something? Yes, I forgot to save it, apparently. Okay, my bad. Let's go back. So this time I save the file. We don't see the little asterisk here. Like whenever the file is modified, by the way, it's going to remind you that it's modified, except that I didn't pay attention to that. So now it's saved. You don't see the little asterisk. So now I can compile it. I can run it. Guess the number 1, 2, 3. And it tells me nope, go to the next line. If I run it again, but this time I enter the actual number that was expected, how did you guess? Okay, so very basic if-else control flow there. The else is optional. So we could actually remove all of this, right? And have a little program that is going to just display how did you guess if I guess right, but if I don't guess right, it's not going to display anything. So let's save it. Let's make sure it's saved this time. Compile it, run it, guess the number, 1, 2, 3. It doesn't display anything. Run it again, guess the number, 42. How did you guess? So all of this should be very, very, very familiar. It's the same logic than whatever language you learned before, with maybe a few minor differences in syntax here. So let's talk more about those minor differences in syntax. Do I need those parentheses here? Well, if you come from Python, you're going to say, no, I don't need those parentheses. So let me save the file. Let me try to compile it. Wow, I do need them in the C programming language, okay? So every time you are going to have an if statement, the condition that you're going to express, that you're going to test in your if statement, has to be encased in a pair of surrounding parentheses like that. Okay, you don't have a choice. What about the curly braces? Can I remove the curly brace here, 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 and here? Well, based on our experience with the parentheses, at this point, you should be a little paranoid about removing stuff, okay? And this is not a bad thing to be a little paranoid with the C programming language. If I try to compile this, however, it compiles okay. So compiling okay doesn't mean that it's working. So let me try to run it to execute the executable file. Well, it seems to be running without crashing, so that's a good thing. Now, does it behave the same way? 1, 2, 3. No. I run it again. 4, 2. How did you guess? So it compiles fine, it runs files fine, and it executes exactly the same way than before. So all of that together would lead anyone to say, well, apparently the curly braces are also optional. Are optional, unlike the parentheses. Well, no, actually they are not. But there is a little trick here that you need to learn as soon as possible. That's why I introduce it as early as now. The C language syntax and the syntax of many languages, if not all, I cannot think of an exception right now. The syntax of any language that use curly braces like that to delimitate blocks of code, generally when you omit the curly braces like here, what you mean is, if this condition is true, I want you to execute one statement, only one statement, this one. How did you guess? If you have more than one statement, no, seriously, how did you guess, right? If you have more than one statement that you want to execute if this condition is true, then not using the curly braces is not an option. I'm going to try it right now, okay, GCC. Now it's complaining about something totally weird. It's complaining about the fact that there is an else here without an if statement. But here's my if statement. Well, I wrote my code the way that I thought about it. If this condition is true, then I want you to do this, and I want you to do that. Else, I want you to do a display of no. Okay, this is how I had the code laid out in my mind. But really, what the C compiler compiled is something that looks like this. If input equal 42, then display how did you guess? And that's it. End of my if statement. No else, nothing. We are done with the if statement. Why? Because there was no opening curly brace here, so that meant the block of code to be executed if the condition is true is just that one statement immediately after the closing parenthesis. And then that's the end of my if else statement because there is no else here. Just as simple as that, okay? So then the printf, no seriously, well, it's going to be displayed no matter what after the end of my if statement. What else? Then I have the keyword else here, but when I encounter the keyword else, this if statement was long terminated. What does it correspond to? There's no if going on here. Okay, so that's exactly what the compiler is complaining about. That's exactly how the compiler sees this code. And all it took is for us to rely on this this rule that says if you don't use the curly braces in an if statement, then only one statement is considered to be part of the block of code to be executed if the condition is true. And then everything after that, well, Everything after that, if you have only one statement, then you are going to find the end of your if, or an else statement, and then again, only one statement. But if you have more than one statement, you have to absolutely encase your two statements. In this example, I have to encase them in curly braces. I do not have a choice, okay? So in this case, I do not have a choice. But what about the printf nope? Well, let's save it, okay? Let's compile it, run it again. So I'm going to always run through the same test, okay? Consistency. Guess the number 123. Nope. Okay, that makes sense. Run it again. Guess the number 42. How did you guess? No, seriously. So we did execute those two statements if my condition was true. I did execute only this one statement if the condition was false. If I wanted, I could obviously add curly braces here, but it would not change anything because I only want one statement. Now if I add two statements, printf again, nope, and then I'm going to add some exclamation mark, save that. So now with the curly braces, I'm going to just trigger the else directly. So I'm going to enter 1, 2, 3, okay, nope, with exclamation marks. But if I remove this curly brace here and this curly brace here, save the file, compile it again, and run it again. There we go, 1, 2, 3. It's going to display, it's going to display nope, and that's going to be the end of the else. But why do I get those exclamation marks? It looks like it's doing the same thing here and here. Well, it's not. It's not doing the same thing at all. And the best way to convince you of that is to change that message and say, this is the end of my if else statement. Okay. So if just changing the message might not convince you. Fair enough. Okay. But let me make my point here. So if I enter 1, 2, 3, I'm going to display nope and end of my if else statement. So is it because those two things are actually executed when this condition is false? No, only this one is executed when the condition is false. And this one here, because I didn't use curly brace, is executed all the time. So really, this is what's happening. Okay? This is how the compiler understands my code. Best way to prove it to you is I'm going to run it again. So I did modify my file, but I didn't save it. Okay, so I'm still running the previous version, not that it would matter, but if I enter 42 here, how did you guess? No, seriously, and then end of my if else statement. Okay, so you have to be careful about that curly brace thing. It's very, very important in the sense that it can actually confuse students at the beginning, especially if you transition from a language like Python that doesn't use curly braces really much to a language like C that relies on them to define the boundaries pretty much of blocks of code. All right, so next topic. We have talked about the parentheses that were necessary. We have talked about the curly braces that are not always necessary, but you have to know what you're doing. What else is there to talk about regarding the good old if else statement? Well, the last thing that I want to bring up to your attention is the equal operator. So it's not something about if else per se, but it's something about the if else and our use of the double equal operator, which means comparison. So there are 6 comparison operators. Equal, that means attest if what's on the left is the same as what's on the right. Exclamation mark equal, which means different. So attest if whatever expression is on the left is actually different from what's on the right, and if it is different, then this is equal to true, otherwise it's equal to false. And then, of course, I have lesser than, lesser equal, greater equal. Okay, so that's 6 of them. Okay, now the common mistake is to write things such as this. If input single equal operator 42. So this time we are not comparing whatever is on the left to whatever is on the right. We're not comparing the content of the variable input to the value 42. What we are doing is we are using the single equal operator, which is not comparison, it's assignment. So we are assigning the value 42 to the variable named input. Does that work? Can we do that in a if statement? Shouldn't the compiler actually tell us you're out of your mind? This is not a comparison. What does this have to do with the if statement? Well, no, the compiler is actually quite happy to accept that piece of code here. And if I run it, this is where it gets interesting. If I run it and I enter 123, so that means that input is currently equal to 123. I meant to compare it to 42, but we know I didn't do that. Instead, I overwrote the value 123 that I'm about to enter, and I replaced it by 42. That's what I did here on line 10, right? And then what's going to happen? Is it going to be considered true to do that, or is it going to be considered to be false? Well, let's see. 123, how did you guess? No, seriously. So it considered that this condition was true, and therefore it executed this code. Okay, very well. Does it change anything if I enter actually 42? No, it doesn't change anything, because no matter what I put in this variable with my scanf, I override it here, right? I replace the content by 42. But how come assigning a value in and by itself, how come an operation such as assigning a value yields a Boolean result, true or false? Well, it's because the C programming language is a lot flexible with what it interprets as a Boolean value true or Boolean value false. We have a Boolean data type. Okay, I talked about it in a different video, but we have also this rule that says everything that is 0 is false, and everything that is different than 0, like for example a positive number 1, 2, 3, 4, 5, etc., or a negative number even, this is all considered to be true. So that's the first piece of the puzzle. So if I wrote something like, for example, if 42, that's a weird condition, right? That means I'm not really testing anything. I'm just saying, okay, here's my condition. Is it true or false? Well, in the C language, 42 is actually true. So let's double check that. Okay, I'm going to save, compile, run it. So now it doesn't care about what I enter, even less than before, right? 123, well, the expression is true. So I'm executing, how did you guess? No, seriously. But what if I enter 42? Well, I don't even look at the number I'm entering. My expression is always if 42. So this is always if true, pretty much. And I always trigger this part of the code here and never, ever consider my else statement. If I add a 0 here, well, the rule is everything that is 0 is false. Everything that is different than 0 is true. So if I add a 0 here, let me save the file, what would happen? Let's compile again, run it. Well, again, what I enter doesn't matter. Every time I end up triggering the code that is in the else statement. Why? Because if 0 means if false. Okay, my condition is false, go to the else. There we go. So why am I bringing this up? Well, like I said, this is half of the solution to the puzzle, right? A number has a truth value. Let's go back to what we had here. If input equal 42. So how did we go from assigning the value 42 to the variable input to this whole expression that I highlighted here right now is equal to a number? Well, that's actually what happened when you assign a value to a variable. When you assign a value to a variable, two things happen. One, the value, well, is assigned to the variable. Okay, that's good news, I guess. So this is what we intended to do. We change the content of the variable, we put the new value inside of it. That's the first thing that happens. But the second thing that happens is an assignment in the C language and many other programming languages is also considered an expression. And the fact that it's considered an expression means that we are going to yield a value. We are going to evaluate that expression input equal 42. We are going to evaluate it also into a value, and that value is going to replace my expression. Just like when you type 2 plus 3, the 2 plus 3 is evaluated, it gives me the result 5, and now I'm looking at 5 instead of 2 plus 3. Well, here, when I write input equal 42, I put the value 42 in the variable input, and then this whole expression, input equal 42, is going to be replaced by its result, the value that it yields, which is whatever value I assign. So here's the rule. When you assign a value to a variable, whatever value you assign to the variable is also what the expression yields to the code around it. And so I end up with what here? I end up with if, as a result of assigning 42 to input, is 42. If 42 is 42 positive, negative, I don't care about positive, negative, but is it different than 0? Yes, it's different than 0. Therefore, it's considered to be true. Okay? So there is an interesting side effect here where just by forgetting to put that extra equal, you went from testing if input contains 42 to actually changing the content of input to 42, and then just because 42 is non-zero, then always this part of the code will be triggered in your if-else statement. If you did something like, for example, if input equal 0, I'm going to display, well, let's be original and creative here. I'm going to display 0, okay? And you probably saw that coming. If it's not 0, then I'm going to display not 0, okay? So it's no longer about guess the number, it's enter and int, okay? Integer. Enter an integer, read the integer. If it's 0, I display 0. If it's not 0, I display not 0. So first, let's make sure that this code is compiling and working, okay? So if I enter 1, 2, 3, not 0. If I enter 0, it is 0. Okay, that's what I want to do. And then let's say that I make that silly mistake again. I forget one of the equal, save the file, compile it again, run it again. This time, if I type 1, 2, 3, it says it's not 0. Okay, and if I run it again and I enter 0, it tells me it's not 0. So again, what happened? Exactly the same thing, but the outcome is the opposite. Exactly the same thing insofar that instead of comparing input to 0, I assign 0 to input. So after I'm done with this, inside the variable input, there is a 0, no matter what I typed. No choice. But also, this expression, input equals 0, was actually evaluated into the value that was assigned to the variable, 0, but 0 is interpreted as false. So I always end up, if 0, always end up executing whatever is in the else statement. Okay? Other than this, so 3 little things that we have to keep in mind, okay, to be careful about. Other than this, the similarities, well, you can actually nest if-else statement inside one another. You can put them one after the other, so this is absolutely not new compared to what you learned before, okay, in another programming language. So I can say, for example, here, if input equals 0, I'm going to display this is 0, else, and I'm going to do if else. And instead of displaying not 0, I'm going to be more specific than that, okay? I'm going to display. So if input is not 0, then if input is greater than 0, I'm going to display positive. This is not what I meant to do. There we go. I need this piece of code instead. So I'm going to display positive, else I'm going to display negative. And there we go. If-else statement, that 2 if-else statements actually that are nested inside one another. And I can compile this and I can run it. And if I enter 1, 2, 3, positive, if I enter minus 1, 2, 3, negative, if I enter 0, 0. Okay? So we can nest the if statement. We can have an if statement come after another if statement. Okay? So for example, here after I decide if the number is positive, negative, or 0, I could say if input equal 42, then I can say printf, you remembered the magic number. Okay? So there we go. And therefore, if I compile this, clear the screen a little bit to run it. So if I enter 1, 2, 3, it's positive. If I enter minus 1, 2, 3, it's negative. If I enter 0, it's 0. If I enter 42, well, it's positive, and it tells me also, hey, you remembered the secret number from the previous program, okay? So we can nest if-else statement as much as we want. Don't go past like 3 or 3 level of nesting is already a good sign that you need to reconsider a little how you're writing your code here and maybe add a little function or something like that. We can put them one after the other, that's serially arranged instead of nested. What else can we do? So these are the similarity, right? So we can also use logical operators. We can write things such as, for example, if a condition, so I'm running out of space here, if, and inside my condition, I'm going to have two terms separated by a double ampersand symbol, which is a logical AND operator. So again, depending on what programming language you studied before to come to C, maybe you just wrote a logical AND like this, with a keyword AND. Well, there's no, in C, the syntax is double ampersand, okay? And we can do things such as, I don't know, if input equal 42 and input testing a value is going to restrict us a lot. So let's say instead if input modulo, I'm going to use the modulo operator, I hope you remember it. If not, I'm going to give you a brief reminder here. So if input modulo 2 equals 0, which is a way to say, brief reminder coming up, if the division, the integer division of input by 2 gives us a remainder of 0, aka if input is an even number. If input is an even number, a multiple of 2, and input is also a multiple of 3, so the remainder of the division of input by 3 is also 0, that's what we are writing here, then I can display printf the value is both multiple of 2 and 3. Okay? So that allows me to have more complex Boolean expression where I have one term here, then logical AND, another term, and I'm not going to go back into the definition of the logical AND, the logical or the logical negation operator, because you already studied that in your first programming language, and the reading assignment is going to do a good job at refreshing your memory if you need a little bit of refreshing there, okay? But what I'm going to say simply is that the same way that you were using the AND, the OR, and the negation logical operator in another programming language, they are going to be used exactly the same way here, okay? The syntax is a little bit different. The logical AND is a double ampersand symbol, no space in between. The logical OR is 2 vertical bars, no space in between. So if I tested if input modulo 2 equals 0, so if input is a multiple of 2 and input is a multiple of 3, so it's not AND anymore here, it's OR. So I would say the value is either multiple of 2 or multiple of 3, okay? And then we have this negation operator. So for example, I can write here if the negation of input equal 0, okay? So that's the same thing as writing if input different than 0. So I completely change the meaning of my code here. If I wanted to kind of like do 2 wrongs, make a right type of scenario here, I would have changed this to different. If input is different than 0, and then negation of that, so if I get a true, I turn it into a false. If I get a false, I turn it into a true. Now I am back to the same meaning. It's just that this is a lot more complicated than just writing, if input equals 0. Why would somebody write this like that? I don't know. But this is just to illustrate, the syntax of the negation operator. In C, we don't write not, we write single exclamation mark, followed by a Boolean expression that you want to negate. Okay, so that's pretty much it for the syntax of our good old if statements. One last thing that I'm going to cover in this video is, and again, that can be something that was different in the previous programming language that you studied. The last thing that I want to cover in this video is that when you start using those logical and logical or operator, there is something going on that is called a shortcut evaluation. So what is a shortcut evaluation? A short circuit evaluation, sorry. What is a short circuit evaluation? The idea of a short circuit evaluation is when you have a if statement, for example, you say, I'm going to read two numbers from the user. Okay? I'm going to call them quite originally input 1 and input 2. There we go. All right. So I'm going to read two numbers from the user. Enter an integer, input 1. Enter an integer, input 2, and then I'm going to have a condition here in my if statement that uses a logical AND operator. So I'm going to say if input 1 is equal to 42 and input 2 is equal to 23, then printf, you guessed both. Okay? So we are just playing around here with some very simple code, right? So I ask the user to enter two values, and then I look at those values, and if the first one was a 42 and the second one was a 23, I tell the user, you guessed both values that I was thinking about, okay? Else, well, else nothing. I'm not going to even bother displaying something. If you didn't guess both, then you don't get a cookie. All right. So what am I going to do with this example to illustrate the idea of short-circuit evaluation of Boolean expression? Well, if I realize, so to win the game, right, if you can call that a game, to win the game, I need to guess both the first number and the second number. And I did the typo here that I told you a lot of people end up doing without paying attention. So, saving point, right? So if I win the game, that means that I guess right the first number and the second number. Okay. So when I'm done here comparing input 1 to 42, if it happens that input 1 is actually 42, I don't know yet if the whole expression is true. I don't know if input 2 is also the number that I was looking for, right? So I'm going to continue and check whether input 2 is 23. Now, if input 1 is 42 and input 2 is 23, that's the meaning of a logical AND operator, then the whole thing is true. Okay. But what if input 1 is not 42? Let's say that I entered a 0 followed by 23. So input 1 is 0 here, and input 2 is 23. So I compare input 1 to 42. It's false. Is there any way that if the first half of a composite Boolean expression with a logical AND is false, is there any way that the outcome of the whole expression will be true? I refer you to your discrete mathematics discrete structure course, okay, on Boolean algebra. No, there is no way. So the C programming language, like many programming language actually, is going to use that to be lazy, but the good kind of lazy, the kind of lazy that doesn't want to do a work that is useless. So what's happening here is that after evaluating this first part of the Boolean expression, if we come up to the conclusion that this is false, then we're not going to even bother evaluating the second half. If we come to the conclusion that this is true, then yes, we need to check the second half, and if the second half is true, then the whole thing is true. If it's false, then the whole thing is false, okay? And the same thing is going to happen with the logical AND operator, except that in the case of the logical AND operator, the rule is kind of reverted, meaning that if this is true, if the first condition of something and something type of Boolean expression is true, then I don't need to look at the rest. I only need one of them to be true for the whole thing to be true. Again, I refer you to your discrete mathematics, discrete structure class. But if it's false, then I need to check the second one to see if there is still a chance that my whole expression is going to be true. Okay? So this is very common in programming language. This is called short circuit evaluation of a Boolean expression. The C programming language does it as well. Very last thing, and this time I promise this is really the last thing. It's not the last thing that was before. So very last thing now, the if statement is a statement. What does that mean? That means that it's code that's going to do something but doesn't yield a value, doesn't result into a value, is not evaluated into a value. What do I mean by this? When you write if, and we're going to go back to something a little simpler here, okay? When you write if input, for example, is lesser than 0, okay, then I'm going to change input and I'm going to say input is minus input. So if it's a negative number, I turn it into a positive number, okay? Well, that's kind of a way to do absolute value, right? Okay, you're going to give me a value as an integer, and I'm going to check if it's a 0 or if it's greater than 0, I don't touch it. But if it's lesser than 0, then I'm going to change its sign. So if it's negative, I change its sign, I bump it back up to the positive. So this is a way to do the absolute value of a number. And I can do a printf here and say the absolute value of your number is, and I'm going to printf after that. So I want to printf a number, an int, and this is going to be the new value of input. Okay? So I have like a little program here that's going to take a number and compute pretty much its absolute value. So let's try it out. There you go. Enter your number 123. The absolute value of your number is 123. Fair enough. Okay? That was a positive number to start off with. So I'm adding just a quick space here. Run it again. What if I give you 0? Absolute value is 0. What if I give you minus 123? Or 132, why not? The absolute value is 132. So we went from minus 132 to plus 132. So why am I using this particular example to make my next point? Because my point is that this is actually, this is a statement. It executes, it does something. However, if I was to say something such as absolute equal if input lesser than 0, absolute equals minus input, else absolute equals input, okay? If I was to write the code like that, assuming that I have a variable absolute here, initialize it to 0, why not? And then display the absolute value as the result of absolute. If I just write, so let me rewind back 1 second here before we go to this version of the example. If I wrote things like this, if input is lesser than 0, then the absolute value is minus the input, negative the input. If it's not negative, then the absolute value is just the input itself. If I write it like this, this is just another way, this is just another way to write exactly the same thing that I had before, okay? So if I enter 123, absolute value is 123, minus 123, exactly, 123. If I enter 0, this is 0. Perfect. It's still working the same way. But this shows you that what you're doing is you are assigning, either a minus input or input to a variable called absolute. Well, what if I wanted to write something like this? Absolute equal, if input lesser than 0, I want minus input, else I want input. So intuitively, you see what I'm trying to say, right? I'm trying to say what I want to assign to the variable absolute is a result of evaluating this expression. And what you evaluate in programming language are always expression. Expression yield values. Statements do not yield values. They do some work, but they don't yield values. So now I'm trying to force my if statement to be looked at as if it was an expression. And in the C programming language, it's not. So that means that this is going to give me There we go, GCC, a syntax error. And the error is pretty clear, actually. It says, when I encounter the if here, I expected an expression. And what you give me is an if statement. Okay? So is there a way for me to write code this way? To say, for example, absolute is going to be equal to minus input if this condition is true, or input if the condition is false? Yes, there is. There is, and the syntax is a little bit weird the first time you encounter it, and the name is even weirder. It's called the Ternary Conditional Operator. So it's an operator, obviously. It's ternary because it takes 3 operands, and it's conditional because it allows us to do what an if statement would do, a conditional evaluation, okay? So how does it work? The syntax, like I said, is a little weird. You have a parenthesized Boolean expression, the one that you would use in your if statement, followed by a question mark. So we test if this is true or not. If what I highlighted right now, my Boolean expression, is true, then this whole expression here, from here to the end, is going to be equal to whatever I put after the question mark. How do I say else? Colon, of course. The colon here is going to mean that if this expression is false, then instead, this whole expression is going to be equal to input. So, this whole thing here, parentheses, input lesser than 0, close parentheses, question mark, minus input, semicolon, colon, input, semicolon. This whole thing here is an expression. So we went away from the if-else keywords, right, that are used for the if-else statement, and instead we used that question mark and colon as part of a ternary conditional operator. Here are the 3 operands. The first is a condition. The second is a value that you want this whole expression to be equal to if the condition is true. The third is a value that you want this whole expression to be equal to if the condition is false. So this is altogether our ternary conditional operator, and it's going to do exactly what we said to do at the beginning, meaning that if I compile it, well, it's going to complain about the semicolon. Oops, I forgot to remove this. Okay, this is supposed to be an expression. No need for a semicolon at the end. This is supposed to be an expression. No need for a semicolon at the end. But we do need one semicolon to close the whole expression, the whole statement here, where we assign a value to the variable absolute. So let me correct this code here, and let's jump back in this terminal window. Now, if I enter 123, the absolute value is 123. Minus 123, it's 123. 0, it's 0. Okay, so I successfully found a way to write an if statement using a weird syntax with an operator that has 3 operands, and that weird syntax represents pretty much an if statement but as an expression. So it's conditional evaluation of an expression. And generally people don't indent it like this, okay? People actually write it something like this, okay? Minus input, else, and when you read it, you can read the colon as else, and then this is the end of my entire line of code. Okay, so generally you are going to see those things like this written as one-liners and inserted wherever you need, to evaluate a condition, and then depending on that condition, you want this whole expression to be one thing or the other, like minus input or input in our case. Okay, and with that, we covered all of the similarities and differences between the good old if-else statement and the version of the if-else statement that you studied in a previous course in a different programming language. So we're going to stop the video here. As usual, if you have questions, please feel free to use Piazza, the forum, whatever we are using this semester, okay? Come to office hours, don't hesitate. And the next videos, we are going to explore iterative statement and then more alternative conditional statements as well. Thank you for your attention.